Want to welcome Alyssa. First of all, it's great to have you, Alyssa.
Thanks, Dave.
Yeah, and for those who don't know or have not heard Alyssa speak in the past, or maybe you're not familiar with her background, you're in for a treat. Alyssa is the CEO and co-founder of WhyLabs, which, if you're not sure what WhyLabs is it's an AI observability company on a mission to build the interface between AI and human operators. Prior to WhyLabs, Alyssa was CTO in residence at the Allen Institute for AI. Also worth checking out, to be honest. That's such a really cool spot, and they're doing so many cool things. So hopefully you can mention maybe one or two things about the Allen Institute as well, Alyssa. But getting sidetracked, sorry. Where she evaluated commercial potential for the latest advancements in AI research. Earlier in Alyssa's career, she spent 9 years at Amazon leading machine learning adoption and tooling efforts. She was a founding member of Amazon's first ML Research Center in Berlin, Germany. And Alyssa is also the founder of, I don't know if I'm pronouncing this right, Riskerd AI, is that right?
R squared.
R squared, apologies. R squared AI, which is a global community of 1,000+ AI practitioners who are committed to making AI technology robust and responsible. I'm very excited for this one. Thank you so much, Alyssa. I'm going to pass the mic to you.
Thank you, Dave. Thank you for the amazing introduction. Like Dave said, my name is Alyssa Visnjic. I'm the CEO and co-founder at WhyLabs. Thank you so much for joining this session of MLOps World. I'm really excited to tell you about the critical missing component in the production machine learning stack. I did spend a few years at the Allen Institute for AI, which is a fundamental research institute, which has two really amazing programs. One is if you are in academia and you want to continue doing research, but outside of academia, but still kind of like in academia, AI2 is an incredible place to do that. If you're interested, reach out to me. And then the second program that they have is an incubator. So they incubate ideas, test the commercial potential of the latest research that's coming out of the AI academia world, and help produce companies like WhyLabs, in fact, spun out of the Allen Institute for AI incubator. So if you're interested in either one of those, please reach out. I'm happy to connect you and see how you can benefit from the amazing AI2 team and researchers. So back to the talk. Today, I'd like to present an open source project that fills the huge current gap in the production machine learning stack. So here's what I'd like to cover in about the next 20 minutes. We'll start with looking at the machine learning stack and talk about what's missing. Spoiler alert, there are many things missing from the machine learning stack, and today we'll focus on something that I believe is the most critical missing component, which is data logging. I'll present ideas on how to design a logging solution for machine learning. Afterwards, I'll present an open source library that implements these ideas and designs. I'll show you how it plugs into Spark and MLflow. I know Matej was here giving a keynote, so very relevant. And then we'll talk about the most common use cases that this library addresses. And we'll conclude with the Q&A. Really excited to have you all here. Let's go. So this is MLOps World, and unsurprisingly, we're talking about machine learning applications. And machine learning applications are delightful when they work and dreadful when they don't work. So if you supported a machine learning application before, you probably have a story or two about how it failed and upset your customers. Just like Andreas here, who got recommended a pepper as a substitute for roses by the Whole Foods algorithm. This is a really harmless failure, but a very frustrating customer experience. And what's worse is just imagine what it takes for the AI practitioner on the other side who is on call to troubleshoot and fix this frustrating behavior. Debugging such undesirable model behavior is so frustrating for AI builders. I've heard that it makes you feel like you're trapped in a Kafka novel. Not in a Kafka stream, that's different, Kafka novel. So since 2019, I spoke with over 150 data science teams in the mid-sized to large enterprises, with the teams who've deployed models to production. And in order to understand their pain points, we were discussing stories about recent failures that they've dealt with. And surprisingly, every single team that I spoke to had a failure story, and they told it passionately. So what you're seeing here is, believe it or not, a tiny sample of problems and stories that I collected over the years. Software engineers in the audience are likely noticing many issues that point to a bad CI/CD practice or the lack of it. And if you're operating a model in production, you're probably nodding right now. Although if you're operating a model in production and you have not encountered any of these issues, I'd love to talk to you, because either you have an amazing machine learning platform and I want to learn from you, or you have issues because these problems are just going and happening unnoticed. Now, typically when we talk about software failures, we turn to the DevOps tools. Now, unfortunately, DevOps tools alone won't solve all of the problems that we encounter in machine learning, because DevOps tools for testing, validating, logging, and monitoring do not transfer well to machine learning systems. Now, this is a really common statement now because we're in MLOps world. Basically, MLOps exist to give the world the tools that DevOps have given us a decade ago, but specialize it in ML. So the reason why DevOps tools don't work well is because traditional machine learning applications can be derailed by fluctuations in the data alone. So no code changes or config changes are required. And in the list of failures that I've been collecting over time, you can see the majority of issues stems from data. In fact, thanks to Databricks and other big data platforms, machine learning engineers are able to build pipelines that process terabytes of data in minutes. This is both a blessing and a curse, because if we look at the 4 core steps in the machine learning stack, processing raw data, generating features, training the model, and serving the model, each one of these steps involves transforming and moving massive amounts of data. When you operate such a stack in production, you quickly learn that each step can introduce a data bug or can be completely derailed by a data bug. So machine learning models are very sensitive to data bugs and data changes. In fact, the majority of machine learning failures stem from data, as I've shown with my field research. Typically, machine learning failures stem from things like missing data, duplicate data, bad quality data, and data drifts. Now, if you're operating a model in production, your most common daily task becomes answering questions about the model behavior and health. Questions like, how is my model performing? Has my model drifted? Some of the questions are simpler than others to answer. However, each question typically involves figuring out what happened to the model and to the data in the past and why did it happen. So think back to the first time you debugged a poor performing model or machine learning application. You check the code, the model version, the infrastructure, only to realize that the problem is actually hiding in the data. So how do you debug the data, test the data, monitor, document, and so on? This is not in any way a novel problem. Every engineer who operates machine learning applications in production has their own improvised way of testing, monitoring, and debugging data. It's probably ad hoc. It likely involves pulling a lot of data from storage, writing complex ETL queries, processing this data, and writing visualizations in your favorite notebook. This can be very tedious. Now, imagine if instead of running this tedious manual process every time your model fails, there was a way to continuously monitor the quality of data flowing through each stage of the machine learning stack. Imagine if you could be alerted about data issues such as data drift, schema changes, data outages, and so on before they impact your model. That would be nice, wouldn't it? So let's say we wanted to design such a data logging concept. What would this data log have to capture in order to provide the most utility to AI practitioners, data scientists, ML engineers, and so on? In my experience working with dozens of machine learning teams, there are 5 core categories that are most crucial to track for understanding how good your data is. For example, tracking the metadata allows you to understand where the different subsets of your data are coming from and how fresh are they. Tracking the counts allows you to ensure that the data volume is healthy and to keep an eye on missing values. Tracking statistics, summary statistics, and so on allows you to identify outliers and data quality bugs. Tracking distributions enables you to understand how the shape of the data changes over time and helps you catch distribution drifts. And finally, you can optionally also keep a small stratified sample of the raw data itself to help with debugging and post hoc exploratory analysis. Now, since logging is going to be part of every step in that machine learning pipeline that we looked at a second ago, we need to be thoughtful about its runtime properties and outputs. Logging cannot be more expensive than running the machine learning model itself. So what are the key properties of a good and useful logging solution? Well, here we can take some cues from the DevOps best practices, since they have already figured out what good logging looks like. And they're merged with the machine learning thinking and data thinking. A good logging solution should be lightweight, so it should run in parallel with the main data workloads. It should be portable, which means that it should be easy to plug in anywhere in your machine learning pipeline, no matter what kind of tools it's composed of. Logging should be configurable. You should be able to, have a plug-and-play setup where you don't have to specify what every feature that you're logging is like, but also it should be really easy to configure to your preferences. And finally, since we're working with data statistics, the logs should also be mergeable. So allowing merging from multiple instances or aggregating logs, data logs over time. So keeping these properties in mind, after many years of supporting production machine learning applications, my team and I at WhyLabs set out to build a data logging solution that makes answering those MLOps questions a breeze and makes enabling data logging really easy. So I'd like to present WhyLogs. And WhyLogs is a purpose-built machine learning logging library, which is open sourced by our team at WhyLabs. WhyLogs is built to provide lightweight, portable, configurable, and mergeable data logs for both batch and streaming data workloads. Check out the bit.ly link on the slide to get to the GitHub page. So WhyLogs is already making lives of AI practitioners all over the world much, much easier because they don't have to think about what to log. They just use WhyLogs. It's available in Python, Java, and Scala under Apache 2.0 license. And for the rest of the session, I'd like to look at how WhyLogs works and how does it make operating machine learning pipelines much, much easier. So going back to your pipeline, it's constantly flowing and crunching data. In some cases, you don't even keep track or record what data was processed. The data is kind of ephemeral. And when you're tasked with answering questions about model and data behavior, you have to reproduce the entire data flow. That's expensive, tedious, time-consuming, kind of a nightmare. WhyLogs solves this problem by logging all key statistics of your data over intervals of time. So instead of reproducing data, you just look at the log file. Now, there are many open source libraries that try to tackle the problem of testing data quality or evaluating for data drift. Packages like DQ and Great Expectations. WhyLogs takes a very different approach. What it does is it implements a standard format for representing a snapshot of data, structured data, images, text, audio, and so on. This allows the user to decouple the process of producing data logs and acting upon them. So WhyLogs provides a foundation for profiling, testing data quality, monitoring, and so on. Now, let's look at a few integration examples. WhyLogs elegantly integrates with Spark. In this particular example, we're taking a popular public data set about wine quality and profiling each feature with WhyLogs. All of this is done in just a few lines of code. Behind the scenes, WhyLogs uses stochastic streaming algorithms to sketch key statistics of each feature. And WhyLogs seamlessly integrates with the Spark data frame API, which allows you to capture the log with basically no configuration from the user. And the WhyLabs UDFs are implemented in Java in this case, taking full advantage of Spark's raw processing power. WhyLabs requires only one pass over the data to calculate all of the key statistics, and the performance of such computation is so efficient, you can run WhyLabs in parallel with your main data workloads. You can even run WhyLabs as an accumulator in Spark. The resulted outputs can be stored in Parquet, Protobuf, and so on for processing and analysis. Now, if you're using something like MLflow to manage the life cycle of your models, you're already storing valuable artifacts associated with each run, such as model parameters and performance metrics. WhyLabs would add a data log artifact to each job with just one line of code. And it's similar to MLflow tracking APIs, where WhyLabs profiles and collects the data in just one line. And using WhyLabs with MLflow adds something like data transparency across your entire lifecycle. The resulted artifacts, WhyLabs artifacts, can be visualized in the MLflow UI, or can be visualized using WhyLabs open source built-in visualizations. Furthermore, the resulted artifacts can be used to continuously monitor data quality, debug data by running a quick exploratory analysis on data at every run, utilizing a bunch of visualizations that are included in the open source library. So here is a sample partial output of WhyLabs on a wine quality data set. WhyLabs captures key statistics per feature, things like counts, distinct counts, summary statistics, and so on. The default configuration for structured data infers the schema and calculates about 30 metrics per feature, from count to cardinality to a full histogram. The log files can be converted to CSV and JSON for easy manipulation. So what you see here is as a flattened version of the log file. And this data contains all information you need to understand the quality, integrity, and distributions of the data in your pipeline without reproducing anything. The type of metrics WhyLabs captures is configurable, and we would love the community to contribute new metrics and ideas, especially for complex and unstructured data. Now, if you're collecting WhyLabs systematically, it enables fantastic transparency into the data that flows through the machine learning pipeline. So in the wine quality example, I used MLflow to run inference for about 20 batches. I used WhyLabs to capture the data properties at every feature in the batch. Now we can visualize the distribution of, for example, the free sulfur dioxide across these batches. Visualizing the distribution over time helps understand distribution drift and data bugs. So here in this example, we can see that there is a spike in the middle right of the graph. And if this data was crucial to my model, I'd want to take a look at this particular batch of data and make sure that there are no problems with it. Now, as we discussed earlier, one of the most important properties of logging is to be lightweight and hence cost-effective. Capturing data statistics should not involve moving massive amounts of data and then post-processing it. Because WhyLabs uses stochastic streaming algorithms, it captures remarkably lightweight data statistics. This approach gives us a constant memory footprint and the ability to log terabytes of data without breaking the bank. Furthermore, the WhyLabs profiles are mergeable. So for streaming pipeline, you can capture micro batches of logs and then aggregate them to hourly batches or daily batches and so on. And the resulted outputs are not only lightweight, they are privacy preserving because they do not keep raw data, only data statistics. Now, because WhyLabs profiles 100% of the data, it accurately captures the distributions of the data in each feature. Capturing the distributions from sample data is significantly less accurate, as you can see in these sampled benchmarks. This chart represents median errors for distributions estimated with WhyLabs versus distributions estimated from sample data. When you're using this information for monitoring for data drift, it's incredibly crucial to capture data distributions accurately. And since WhyLabs processes 100% of the data, you will never get false alarms. So going back to the initial conundrum of testing, monitoring, debugging, and documenting data, we developed WhyLabs initially to capture the data necessary for monitoring data quality, data drifts, and model performance. When we open sourced the library, the AI community found additional ways of using WhyLabs outputs. For example, WhyLabs can be used to test the data. To do that, first you generate a WhyLabs profile from a batch of data, say training data. Then you extract the constraints from the WhyLabs output. And these constraints can be used, for example, as GitHub actions to check new data at every commit. This is especially useful for unit testing complex data transformation pipelines, which are some of the most common steps that generate data bugs. In addition, WhyLabs can be used for monitoring. Again, you capture the WhyLabs profile at some point where you want to establish the baseline, maybe in your training data, maybe at the first day when your model is running. And then you use that baseline to check against the WhyLabs profile that's captured on the particular batch during inference. And with that, you're able to identify data drifts, missing value spikes, duplicate value spikes, and so on. To sum up, more and more data science teams are using WhyLabs to enable operational activities for machine learning applications. WhyLabs has integrations to make it easy to plug in into any Spark pipeline, any Python or Java environment, and any of the popular machine learning frameworks. Capture WhyLabs profiles during raw data ingestion steps, during feature transformations, during model training, during model serving. Basically, you'd want to capture WhyLabs at any point where there is a data transformation in your machine learning pipeline. And inference is also data transformation. So by systematically capturing and storing such log files, you create a record of data quality and data distributions and along the entire process. By comparing log files from different places in the pipeline, you can build data unit testing, data quality monitoring, performance monitoring, and debugging dashboards. So this elegant open source library does not involve changing the architecture of your current workflow or of the way you do things day to day as a data scientist or a machine learning engineer. Just with a few lines of code, you add powerful transparency and auditability to the AI application and enable a wide range of MLOps activities. Now, check out the bit.ly link here on the left side of the slide. This link leads to the GitHub package. Give it a try, give us stars, give us feedback, open feature requests. We're actively developing this library. Try WhyLabs and be amazed at how much easier it will make your day-to-day machine learning operations. And please send us your feedback, contribute, help us build integrations into your favorite data tools, and extend the concept of data logging to new data types. Join the effort of building a new standard for data logging. Thank you. I'd love to take questions now.
Okay, thanks, Alessya. That was fantastic. And we do have some questions here. If you toggle over to the chat. So, all right. Oh, what was the name of the institution you mentioned? Please ask Natalia. That was the, I believe, the Allen Institute for AI. Okay,
yes.
Yeah, thank you, Evan. Where do we get a copy of the slides? So we'll be sending the videos after the editing process, which is usually 1 or 2 weeks after. Maddie, so this is one of the most helpful sessions so far. It's a nice compliment.
Thank you.
And we have the link, and Hal also says, so using WhyLabs platform, can we instead send the log data to the other platforms like Splunk? Can you explain, Alyssa, the benefit in using WhyLabs here?
Yes. Hi, Hal. Thanks for your question. Yes, absolutely. You can, so the WhyLabs library generates protobuf, JSON, CSV outputs. You can send these outputs to, let's say, Splunk or Datadog or some other favorite logging platform, or you can have a combination of Prometheus and Grafana and so on. So the output is completely at your disposal, and you can always also try the WhyLabs platform if you want to see what are the types of things that you can monitor. In fact, I'll send a link to trial. We have a sandbox of a platform. I just sent a link to it. And you can see what are we able to build on top of WhyLogs.
Very cool. Okay, so we have some other questions. Amar asks, question, big clouds are all copying ML flows workflows such as flow.log, metric, etc. Are you finding people using WhyLabs in cloud, such as SageMaker environments, or mostly for custom architectures? Great question.
Yes, thank you, Amar, for the question. Absolutely, we do see cloud environments use WhyLogs to enhance the type of logging that is possible. So specifically with SageMaker, you could log data statistics, but you have to specify and configure every feature that you would like to log. With WhyLogs, it does easily plug into SageMaker, to Azure's ML ecosystem, and to GCP, like the TFX extended. So you could essentially enhance any of these flows that have log metric workflow with additional data statistics. And you can use it for custom architectures. So anything that runs in Java, Python, Scala, and we even have a containerized version. So even if you're, a Go person, you could definitely get value out of WhyLogs.
Okay, so Evan asks, what types of values might one log about natural language data?
Thank you, Evan. Great question. So for natural language data, you'd want to log, the tokenization of your data. You can log, depending on the type of data you're working with, you can log the length of each character or the length of each token. You can log character frequency maps. You can then log embeddings, for example. We have a feature for that. And then you can calculate distances between clusters and embeddings and so on. Would love to brainstorm with you, Evan. Reach out, and would love your feedback on what we currently log and how we can extend it.
Thank you, Alyssa. That's a great point. Anybody that wants to speak with Alyssa, obviously just clicking on her little icon there, and you can send her a message for follow-up. And I'm sure she can give you her Twitter and so on, so you guys can keep in touch. So William asked, can you go over again the difference between WhyLogs and Great Expectations?
Yes, thank you, William. So the big difference is that there is a decoupling step. So WhyLogs captures all of the statistics. It doesn't act upon it. It lets the user figure out how to act upon it. So you really log it, you really capture a log of the data or the log of the statistics, and then you can build things like unit tests and data quality monitoring steps. That's one difference. And another difference is WhyLogs is platform and environment agnostic. So if you're running things in Spark, if you're running things in Java, if you're running things in any Python environment, WhyLogs easily plugs into those environments. And the big difference is that because we use stochastic streaming algorithms and data sketches in the back, you can process terabytes of data incredibly fast. So those are the key differences.
Okay, Marias, can you explain quickly what is recorded in the logs? For example, log a data frame, and then Mari's going to study. I'll do my investigations later. That's good.
I will just really quickly recap. So per data frame, out of the box, there are about 30 different statistics captured per each feature in the data frame. Everything from counts, unique counts, detailed distribution of the feature, top key values, and so on. The GitHub page has documentation that outlines all of the things that are logged out of the box, and then you can log custom things.
Cool. Janas, can data be saved locally?
Yes, data can be saved locally. In fact, by default, WhyLogs recommends storing things in protobuf because it's super lightweight. So essentially from a model that has, or a data transformation job that has, 200 features, you will end up with a log file that is only a few megabytes in size. It's very effective to store them and then look at them when you need to run an investigation. There's also a converter inside the open source library that gives you the JSON and the CSV flattened versions of the log files.
Very cool. Arman, a crowd favorite and regular. What's up, Arman? Yes, anything on the product roadmap on anomaly detection from the log data? Oh, yeah, cool.
Yes, thank you, Arman. Great question. Absolutely. So if you check out the try.whylabsapp.com, this is our sandbox, and it shows what we have been building on the platform side for kind of consuming WhyLogs, organize them in the time series data store, and then running anomaly detection on top. Now, that's on our platform side. On the open source side, we are building and releasing into the open source anomaly detection to kind of couple things with GitHub Actions or give you reports per one scan of the log files, what things kind of stand out as outliers or skewed distributions.
Will the WhyLog influence the performance of the app/server?
Great question. It does require a little bit of memory to run. However, the memory footprint is constant. Again, if you go to the, let's see, I'm just going to share the benchmark. So if you go to the Java package, it gives you really, really nice benchmarks to give you a sense of, oops, Alyssa lost her tab. It gives you a sense of the compute requirements and how little it requires, especially if you're running WhyLogs alongside with Spark. There, you can basically run WhyLogs as an accumulator. So the memory and performance footprint is really minimal.
That's fantastic. So with that being said, I don't see any more questions. Yeah, checking the poll, 30% of the people that mentioned anything on the poll mentioned that this presentation resulted in mind blown.
Thank you.
Great. I suspect that's going to be on the higher side. So thank you so much, Alyssa. It's been great to have you here. You've been doing great work. I hope you keep it up. I'm very curious to see how this grows, develops, matures. I'm very excited for it. And I'm very grateful for you spending the time today with us.
Thank you so much, Dave, and thank you everybody in attendance. Looking forward to your feedback on WhyLogs, contributions to the open source, or just ideas. We also have a Slack channel that I'll share in the general chat.
Yeah, and if anybody wants to keep in touch with Alyssa, as she mentioned, you can send her a quick message on the chat here. Just click on her little icon, and you'll pull up a private chat where you can request to get our emails or contact or whatever it is. Thank you so much, Alyssa. And for those who are here for the last sessions of the day, we have 3 more going on. We have Golson from Udemy. I never know how to pronounce that, but they're going to be going into their platform, kind of opening the hood and letting us know a little bit about how they've structured that and the models that they're running in production. I'm excited for that. Also Yelp and their quick deploy model serving and ranking systems. Talal's going to be explaining that. That's pretty cool. And then Jim, who's located in the Rocky Mountains in a very isolated and excluded place. I don't even know how he has Wi-Fi connection, but Jim is going to be talking about the difference between MLOps and ModelOps. So those are the last sessions of the day, and then I hope you guys join us for tomorrow. We'll have a lot more sessions going on as well. And then lastly, I noticed in the polls that not many people have gone to the booth to register for free stuff. It's a click. You might win a $100 gift card, Amazon card, Starbucks card, Uber Eats, some free headphones. There's a lot of good stuff there. So if you get a chance, go over to the booths and just give a quick click. And then by the end of the day tomorrow, we'll be giving those prizes away. Okay, so thanks, everyone. We'll see you in the last sessions of the day. And hope to join you tomorrow when I'll be back on screen again. Okay, enjoy. Thanks for tuning in.